Good day, students. Welcome to our science class. I am Regina Season and I will be your teacher for today. Before we begin today's lesson, make sure that you have with you your modules, a piece of paper, and a pen to take down the important details of the lesson. For today's lesson, you are expected to acquire the learning objective that is to explain how land masses and bodies of water affect the typhoon. Are you ready? Let's start. Did you know that every year the Philippines is hit by typhoon? And no part of the country is spared. All provinces have been visited by a typhoon at one time or another. In recent years, the Philippines had been overwhelmed by powerful tropical cyclones, where countless deaths and destruction to properties were observed. We cannot stop it from happening, but we can avoid it. And one is by understanding it. Can you still remember what typhoon is from your lesson in day 1? So what is a typhoon? A typhoon is a violent tropical cyclone in meteorological term, which is a low-pressure system occurring in the tropical oceans. The winds above the ground circulate around the center counterclockwise for a typhoon occurring in the northern hemisphere, and clockwise for a typhoon occurring in the southern hemisphere. Tropical cyclones is characterized by rapid rotating storm system by a low pressure center, strong winds, and spiral arrangement of thunderstorm that produces heavy rains. They are warm core, low pressure system associated with the spiral inflow of mass at the bottom level and spiral outflow at the top level. Tropical cyclones always form over oceans where sea surface temperature and air temperatures are greater than 26 degrees Celsius. The air accumulates large amount of sensible heat and latent heat as it spirals toward the center. The tropical cyclone receives the heat from the sea and the exchange can occur rapidly. Because of the large amount of spray thrown into the air by the wind, the energy of tropical cyclone is thus derived from the massive liberation of the latent heat of condensation. When we say latent heat of condensation, this is the energy release of water vapor condenses to form a liquid droplet. You may have wondered what is the difference between a typhoon, a hurricane, and a cyclone. So let's take a look at this map to answer that question. Hurricane, cyclones, and typhoon are all types of tropical storm. They are basically the same thing, but they are different names depending on when, where they appear. Hurricane are tropical storm over the North Atlantic Ocean and Northeast Pacific. Cyclones are formed over the South Pacific and Indian Ocean, while typhoon are formed over the Northwest Pacific Oceans. If you are to observe the path of the tropical cyclones, notice that they never cross the equator nor do they occur nearest. And now, what are the different categories of tropical cyclones in our country? First category, we have what we call the tropical depression with a maximum wind speed of 35 to 64 km per hour. Second category is a tropical storm with a maximum wind speed of 65 to 118 km per hour. Third category, we have what we call typhoon, having a maximum wind speed of 119 to 200 km per hour. The last one, we have what we call the super typhoon. Its wind speed is greater than 200 km per hour. Did you know, class, that in the Philippines, we call the same word for all categories of tropical storm, and that is bagyo. Where do tropical cyclones form? Yes, over the ocean. Remember, the tropical cyclones need water vapor to form. They form in the ocean, which is a better source of water vapor through the process called evaporation. Now, where do you think would evaporation be greatest? Near the equator or away from the equator? Yes, near the equator. Why? Because the sun directly shines at the equator, and so the heat is concentrated on this area where just good enough to warm the ocean water and can produce great amount of vapor to form a tropical cyclones. But take note, not all parts of the ocean can provide a water vapor, especially on latitude away from the equator. According to scientists, the temperature of ocean water must be 26.5 degrees Celsius. Let's see, how do typhoon form? As mentioned a while ago, a typhoon form over the ocean. But ocean must have warm water with the sea surface of at least 80 degree Fahrenheit or 26.5 degree Celsius. First, the warm water evaporates and the moisture rises, creating a thunderstorm. Second, winds spiral upward and outward. A low pressure system forms over the ocean surface. Third, clouds form in the upper atmosphere as the warm air condenses. Fourth, the entire storm system starts to spin counterclockwise and clockwise depending on the hemisphere. When the winds rotate 74 miles per hour, a Category 1 hurricane is born, or in the Philippines, a typhoon category is being born. And that is the process. How do typhoon form? This shows a super typhoon as viewed from up above the Earth. A typhoon looks the same, only smaller. See the clouds in a spiral arrangement? They are being blown by the wind in a counterclockwise direction. Did you know that in a super typhoon, the wind speed is 200 km per hour? This is two satellite images of tropical cyclones, and that is how tropical cyclones look like on top. You already know what is a typhoon and how do they form, right? But do you know what is inside of it and the different parts of a cyclones? Why do you think it is very dangerous and destructive, that it can cause a lot of damage in agriculture, destroying plants, trees, and crops? This shows a dissected part of a tropical cyclones, labeled A, B, C, D, E, and F. A is the location within the eye. B, C, and D is the location far from the eye, E is the eye, and F is the eye wall. To understand more, let us study this illustration. It shows the different parts of a tropical cyclone. First, the eye is a relatively calm area, approximately 38 to 42 kilometers wide. Second, we have the eye wall that composed of dense clouds that contain the strongest winds in the storm. And we have the rain bands that compose of cloud system and precipitation that are stretched out in a long line or band. They range from a few miles to tens of miles wide and 50 to 300 miles long. A tropical cyclone central eye can be cloud-free when it is very strong and cloudy when it is weak. The eye is the area where winds and rains are light and mild. Surrounding the eye is the eye wall, which is the most intense part of a typhoon. Eye wall storm contained high winds and heavy rains. To describe the wind speed and air pressure in the different parts of the typhoon, keep your eyes in the eye of the typhoon. Can you describe the air pressure in the eye of the typhoon? Yes, you are correct. The air pressure is lowest at the eye, and this is the reason why the surrounding air blows toward the eye. What about the wind speed surrounding the eye or the eye wall? The wind speed is greatest at the eye wall and at the dense cloud surrounding the eye. So when the news report quotes wind speed, it is referring to the wind at the eye wall. As the tropical cyclones leads, the other side of the eye wall can still do much damage. Is it clear now to you how to describe the wind speed and air pressure in different parts of the typhoon? Okay, very good. But do you know what will affect the typhoon to strengthen over water and weaken over land? Have you ever wondered why this is the case? So let us find out how land masses and bodies of water affect the typhoon. Cyclones, hurricane, and typhoons are very high energy storms that can release the energy equivalent of an atomic bomb every second. All that energy must come from somewhere, and in the case of a cyclones, the energy comes from the heat of the top several inches in the ocean. But where does all that force come from? Air warms up much faster than water or land, and warm water radiates heat more efficiently than either air or land. The heat coming from the surface layer of the ocean drives updraft and evaporated moisture upward. When the moisture condenses, it forms clouds and winds begin to swirl around the center. At this point, because the heat of the ocean still adding energy and creating updrafts, the air pressure at the surface drops, creating a depression. The energy continues to build in the developing storm even when the rain begins to fall, because the energy going into the storm exceeds the energy being lost. The storm now becomes a typhoon when the circling winds reach a sufficient velocity. The cyclones continues to get stronger as it continues to receive more energy from the surface of the ocean. and that is the effect of bodies of water to typhoon. In a very general sense, typhoon gain power as they move over warm water and start losing energy once they are over cold water. When a typhoon makes landfall, striking an island, especially a mountainous one, could cause its circulation to break down. If it hits a continent, a typhoon will be cut off from its supply of warm, moist maritime air. In the Philippines, the Sierra Madre mountain ranges acts a typhoon barrier, weakening incoming typhoon from the Pacific Ocean before reaching mainland. Technically, landform and bodies of water on and around the Philippines affect the strength and weakness of weather phenomena such as typhoons. Notably, landforms lessen strength of typhoon whenever the winds impact them. Moreover, oceans wherein typhoon originate provide a higher rainfall and strength. And that ends our lesson for today. Did you understand it very well? If not, you may go back to the lesson presented in your module. If today's lesson is very clear to you, congratulations! You may now answer the exercises in your module. Good luck!